Can students really prepare for these A-level papers? I mean, if you look at some of these questions, you can go through the question, you can look at the solutions, but does it prepare you for what's to come in the next year's paper? In this video, we will be discussing some of these caveats that come up on past exam papers, the kind of questions that are most common, the kind of questions that are like curveballs, and we'll share with you some of our tips to help you along the way. So stay tuned.
If you just do standalone paper from last year, then it won't be enough.
If you look at the old legacy papers, right, you could take some of these papers, maybe several exam years, do those papers, and you would almost certainly, I would say, but obviously nothing's certain, you would find those comfortable questions coming up again. And you might have the odd, the question that might throw people off. Now, these new exam questions on the A-level papers, paper 1, paper 2, some of these questions that have been coming up, they're not the same again.
There is an element of similarity, but proportion-wise, it's much lower than the old legacy papers, I would say. The modeling question is now occurring a lot more frequent than the...
Let's start off with the modeling questions that are quite similar, that they are coming up quite often, and they, a student can do it on one paper and pretty much get that same question on another paper. What are those?
One that comes to mind is the modeling with logarithms.
Mm-hmm.
So you may have y equals to ab to the power of x,
Mm-hmm.
and then you have to use logarithms and turn it into a linear format.
Okay, so that's quite common.
It's quite common because it's follow the same structure. So you link that to a linear properties of a gradient intercept and use those figures to work out the unknown values within the...
So that's a question that students should try very hard to learn, because
it's quite frequent, and the structure mostly is the same, that you interpret the...
Brilliant. Okay, so we've got one, guys, yeah? So modeling with logarithms, that's something that would be quite similar. Give me another one.
Modeling with trigonometry. So looking at the
r-cos thing?
Yeah, because before they used to ask you to work out the alpha values and then formulate.
Can I just ask something about that? I'm noticing, like previously with my A-level students, I used to teach them the whole finding the r, finding the theta, the angle, putting it together, and then modeling it, with the maximum and the minimum. And that's kind of not there anymore. What does this mean? Does this mean that we're heading towards a new style of questioning for that, and that knowledge is not going to be required?
I wouldn't say so. I mean, it's true that recent papers, they gave you the equation as, with R and alpha values already worked out, and you just have to use them.
But it used to be so popular before. They should. I would tell my students, I said, listen, learn this, because this is coming up. This is going to be marks for you.
It came up where they gave you the actual form, and then you have to use that to work out the unknown values within that form.
So do you think it's just a one-off, and they should still continue learning that technique?
They still have to learn it, because it's not that there's no guarantee that they're going to stick.
They're going to need to know the knowledge of what's maximum minimum anyway.
Yeah, and they may go back to the old form of working out the R and alpha. Working out the R and alpha values is the initial phase of building up the formula needed to,
and then doing the rest of the stuff. So the part C and part D.
It's like the foundation to it. So it's like, definitely do that, because it will improve your understanding.
Okay, so these are the common type of modeling questions. What's quite uncommon?
Okay, so ones that hasn't come up that often. A couple of years back, there's modeling with modulus graph came up. I remember I mentioned that they could even throw in their modeling with a modulus graph, and it came up.
Now, why we're talking about modeling so much is because modeling is something that is coming up several times across papers 1 and 2, right? It's not just a one-off question. There's so many types of modeling questions, and I feel that students really need to be well prepared, knowing how to apply you were talking about the differentiation one as well.
The whole point of applied maths is applying. Yeah, so you use your maths that you've learned and applying to real life scenarios. So that's what the modeling questions are, where you have to, there's different problems out there, so you have to pick the right type of model, right type of maths to tackle those types of problems. For example, when you're modeling the population growth, mostly it's done by exponential functions. So if you know all the ins and outs of how to analyze an exponential function, like how to differentiate, how to integrate, how to solve equations with exponential functions, how it can also lead to quadratic form of exponentials, know what the graphs look like, so you can then use those properties to tackle questions in that you may find in real life.
So essentially, the problem could be taken from any real life scenario, and bought into the A-level questions.
It could be any form of maths equation, for
Required.
example. You can actually best fits the
The model.
problem that you're trying to analyze.
So it could be differentiation, integration,
trigonometric graphs,
and
could even be quadratics, linear.
And this is the reason why there are so many different types of modeling questions in these exam papers.
You will see that most chapters in the textbook is associated with a modeling question because it's application. It's where can you apply it to real life scenarios. So after you've learned the maths knowledge has to be good enough to be able to apply it to in the modeling question. So if you know how to solve exponential equations, for example, then next phase is to apply it to modeling questions.
So you've still got to know your maths. You've got to know how to differentiate, integrate, deal with your exponential, your logs,
and
everything else.
And fractions, changing the subject, fraction arithmetics, and using algebraic fractions.
Because like
partial fractions.
I mean, some students are coming out and they're saying things like, we've done the last few years' papers, and then we get given this paper in this exam series, and it's like it's not like anything we've ever seen before.
I think what we need to do is look at percentage-wise in the past papers. What percentage of question were just testing the maths knowledge, and what percentage was application within the pure papers.
Because I mean, if you look at the first one or two questions,
if you're looking at getting a C grade, maybe is it enough just to do the maths questions, the maths questions,
the mechanical side of things? That's a good point. That's a good point.
If there's enough marks there for you to get a certain grade, then obviously just focus on those
without doing that extra thinking outside the box.
Spend more time on those questions and go back and check for errors. But if you want to go beyond that grade, obviously, then you're going to have to do some modeling, and
a lot of modeling, not just some modeling. A lot of modeling.
Even in the modeling, there will be parts you can actually answer, like interpret this or solve the equation.
So are you saying here,
they'll give you the equation, work out the unknown. Maybe you could do bits and pieces of it.
So are you saying this so sometimes the part A, B of a question might be strictly dealing with the modeling, finding the A constant, whatever, right? Are you saying that if you can't do that, sometimes you can go down and rather than giving up altogether on the question, you can go to the part E section and interpret this and use what they've given you again.
Sometimes the maths builds up to the equation you need to answer modeling one. So in that sense, there are parts you can actually apply without thinking too much into the what the question is asking. Without too much into context.
I see the point you're trying to make. Like, for example, if we go back to that r cos theta thing, the questions used to say, make the r cos theta, find the r, find the theta. And then once you've done that, you've got yourself some marks.
The second half is now on the
but because they've already shown that to you, and if you can't do that, you can still continue the rest of the question. And that way, you're not completely defaulting on all the marks. You're still gaining some of the marks there.
Amongst a few papers, like, they can't do part A, and even though it's a show question, you show this and then do the rest of it. It's like, even if you can't show it, and you can still use a result to answer some
that they give you, the result that they provide.
It could be like get to that trig equation, and if you then after that is solving that trig equation, and that
part you should be able to do. I see that. Anything else?
Have a list of all the different types of modeling questions that has come up. Try to do as many as you can.
So keep practicing. I mean, everyone says that keep practicing. But what do you do when you practice?
As you find those questions, maybe you take a snapshot of a picture of that and file it, in your folder. Print it out, find the folder. Okay, these are all the questions I've done on modeling with logarithms. Okay, as many as you can find. It's a sense of completion. Like, I've done enough on this type of modeling question. Anything they throw me using similar ones, I'll be able to answer them. Okay. It's that confidence that you need to build as well by banking all the work they've done, and by looking at how much you've done, it will give you confidence.
I just had a thought here, because this is one of the suggestions I used to give. Never ever think that just because you've done a question once that you know it. One of the tips I'd like to give you guys is, number one, go through it again yourself. Number two, try to teach it to others, because when you learn something, you probably learn around 70% and then you start losing it. When you teach it to somebody, you're actually repeating it back to yourself. You're sometimes having to explain it verbally, and then if it makes sense to that person, then you've understood it yourself, obviously. So that's a good practice that I'd like to give you guys. Teach others, because this is why we as teachers, because we teaching this every year, day in, day out. So if you find an opportunity to help others, maybe someone who's struggling with A-level maths, or even GCSE, if you're a GCSE student watching this, always teach to others, because that way two people benefit, you and the other person. Any other tip you'd like to give?
I think that's the main one.
Yeah. Listen, guys, we are going to be doing the solutions for the 2023 paper for A-level maths and for the GCSE. So please stay tuned for that. Make sure you give this video a like. If you haven't subscribed, what are you doing? Yeah, why are you watching this unsubscribe? Give that subscribe button a click right now, guys. Yeah, thank you. Love you guys. Appreciate it. Bye for now.